Hey guys, this is Mr. Gordon here with the Unit 2 Quiz 2 review. So you guys can see this is the first problem that you see on the review. It's to check your understanding coming from page 242. So it says scores on the critical reading section of the SAT reasoning test are approximately normally distributed with a mean mu of 502. So the mean is 502 and the standard deviation sigma of 113. So standard deviation is 113. So it says to sketch the distribution. So as we talked about with today's example in class, we want to start with the mean in the middle. So I can set my mean here at 502, and I want to use a scale that follows my standard deviation. So if I do 502 plus 113, that gives me 615. So my next value is going to be 615 there. Add another standard deviation to that. I get 728. So that's my next value there. Add another standard deviation there. I get 841. So that's my final tick mark there that I'm concerned about. Now on the other side we go in the same direction, but we subtract 502 minus 113. Dab it up it up. That's going to be 389. So this guy here is 389. 389 minus 113, that's going to be 276. And then 276 minus 113, that's 163. So that's 3 standard deviations above. So this is 1 standard deviation above, 2 above, and 3 above. This is 1 below, 2 below, and 3 below. So we're covered. Now to sketch the curve, remember we said the tips are going to fall right out here, 3 standard deviations to the outside, and we know that the mean has to occur right here at the point of symmetry of 502. So based on that, I can go ahead and fill in the bell curve shape that I know all normal distributions follow. Because remember, we're always referring back to this chart. This is what a normal distribution looks like in general. So this is like our guiding light for normal distributions, is this chart right here, and you need to have this memorized. So what percentage of students score between 389 and 615 on the verbal section of the SAT? So between 389 and 615, that's within 1 standard deviation of the mean. So I look back to my guiding light and I think about what percentage of the data falls within 1 standard deviation of the mean. Right there, 68% of the data. So that's 68%. Now, what percentage of students score over 615 on the verbal section? So we're looking at this range right here, over 615. So that's only above 2 standard deviations. So let's look back at our guiding light here. We're looking at this section, above 2 standard deviations. So if this range is, well, let's think of it this way. We know that that's the point of symmetry. So we know that this whole side is 50%. Now we know this yellow area is half of 68%. So half of 68, that's 34%. So to figure out what's remaining here, we just need to do 50 minus 34. That's 16% remaining to fall in that range, which is above 1 standard deviation from the mean. So we know that the answer to this question is going to be 16%. 16% of the data falls in that range. And then if you score a 389 on the verbal section of the SAT, what is your percentile? So again, as we discussed at the end of class, to figure out the percentile, we want to figure out how many people, what percentage of people fall below 389. So this was 16% up here, and it's symmetrical, so this is also going to be 16% down here. So 16% of people are below this guy right here who got a 389, so that means he's in the 16th percentile. Cool. Now, Unit 2, Question 2, this is a good one. Again, it says that a histogram of the average number of points scored per game by the individual scoring leader in the National Basketball Association, the NBA, as it's commonly known, for 54 years from 1954 to 2007 is given below. The question is, what are the mean and standard deviation of this approximately normal distribution? So we know, since it's a normal distribution, that we can follow our guiding light here, this chart, so we can reference back to it. The question is, we want to figure out what's the mean and what's the standard deviation. So the mean is going to be whatever is the line of symmetry for our bell curve. So I've got to draw a sketch of a bell curve here. And again, it's not perfect, that's okay. So I sketch my bell curve like that. So I want to look and see what the mean is. What's the middle line for that set of data? So if I do that, it falls right there at around 32. That's the middle line. So the mean's about 32. Now, based on that, we can figure out the standard deviation. I want to partition this graph so that it looks like this yellow section here. So I need to find that partition, those two lines that are going to cut out the middle 68%. So if I approximate, that looks like it's going to be right here and right here. That looks to me like the middle 68% of the data. That's just my best approximation. So what's the distance from the middle, the mean, out to this one standard deviation above, 32 up to 36? That's a distance of 4. So the standard deviation is about 4. Again, it's approximate. If you had said, oh, it's right here, and you had gone with 5, I'm okay with that too, because we're approximating. And last up, we have this question. So this is a challenging question. If you can do this, you'll be ready for the quiz, far and above. So it says the town has 685 households. The number of people per household is normally distributed with a mean mu of 3.67, standard deviation of 0.34. So approximately how many households have between 2.99 and 4.01 people? So the key here is that it says this is normally distributed. So we know we can reference back to our guiding light, this chart here. And all of these things will be true for this situation. So the mean is 3.67. Now, 2.99, the question is, how many standard deviations is that below the mean? And 4.01, how many standard deviations is that above the mean? So 3.67, if I add 0.34 to that, I get 4.01. So that's one standard deviation above. But 2.99, if I subtract 0.34 from 0.67, I don't get to 2.99. I have to subtract it twice. So I'm actually subtracting minus 2 times 0.34 gets me to there. So this is 2 standard deviations below the mean. So 1 standard deviation above and 2 standard deviations below. We need to reference back to our guiding light to see what percentage of the data that is. 1 standard deviation above and 2 below. So we know that this is 68% right here. We know that this whole range here is 95, which means the green pieces have to be 95 minus 68, which is, my mind's blanking, 27. So each green piece is half of 27, which is 13.5. So we're not concerned about this part. We're only concerned about this range right here. So 68 plus 13.5. So that gives me 81.5%. So 81.5% of people fall in that range. So it said the town has 685 households. We have to figure out what's 81.5% of 685. So we can just do 0.815 times 685. And when we do that math, 0.815 times 685, we get 558.2 275. So right here, C, 558 households fit in that range. That's our answer. So every single question that we're answering here comes back to this, our guiding light. So this is what you really need to be able to know and produce on the quiz tomorrow. If you don't know this, you're going to be stuck because you're going to need this as your guiding light. So wish you guys the best studying. Have a great day.